Dear friends and members of the KITION Planetarium Observatory, good evening. One more Tuesday, last Tuesday of every month. As you most probably all know, we're having another science cafe. This time we have something very special, and we're going to talk about the James Webb Space Telescope, and we're going to compare it with Hubble Space Telescope. Now, most of them talk about it as its replacement, but NASA refers to it as its successor. Now, we had also we were so lucky last week to attend an event that was organized by the CCO and the United States Embassy of Cyprus. And we met Dr. Alexandra Lockwood, the NASA scientist who is responsible for the James Webb Telescope project. And thanks for the invitation to Mr. Danos and the embassy. Dr. Alexandra, she presented herself as a project scientist for the James Webb Space Telescope. She's chief scientist for the project. She described in what spectrum, which part of the spectrum the James Webb Telescope will be observing, and she presented the first images that she showed the world in between the 11th and 12th of July 2022. So, and she also mentioned that she was not with her children on December 25th, 2021, because it was Christmas, of course, but she was on the launch. She was working because it was the time it was launched in space. And because it was bigger and they had to use a bigger rocket, and they got the rocket from the European Space Agency, Orion 5 rocket. She also talked how important it is about learning about the biosignatures in the atmospheres of other planets. And if we have a closer look at this one, it most probably will be announced very soon if will be proved that they discovered some, of course, methane and carbon dioxide in this atmosphere. But what is most important here, except that they have discovered the carbon dioxide in the atmosphere, dimethyl sulfide, that as far as we know on planet Earth, it is being released in the atmosphere only by phytoplankton, in Greek, phytoplankton. So if they can prove it, it means that they will announce that most probably there is some source of life in that exoplanet. But we'll have to wait for them to announce it when they confirm it. And she also talked about how they find the exoplanets when they pass it in front of their stars and the brightness changes, but also how they study the atmosphere, both in front when the starlight is affected, and also at the back of the star. There's another way that they check it as well. And she also talked about the future. So what's coming next after James Webb Space Telescope, and she talked about the Habitable Worlds Observatory that will be launched to find, to search only for planets in habitable zones. And most probably, as I asked her, and she promised that she will be attending one of our science cafe as a guest lecturer, and she will be talking about herself, so I will not eat her breath, about the discoveries and about what will come next. So that was just a summary, brief summary of what she presented. She will present it when time comes herself. I will go through the comparison that NASA presents to the public, comparing the Webb, James Webb Space Telescope and Hubble Space Telescope. As you know that the Hubble Space Telescope was out there for many years, and since 2021, and in December we have James Webb in space, and of course after July 21st, we have 22. We have the first images, and all the time we get lots and lots of new images coming. Now, what is you see here the electromagnetic spectrum and the satellites that are presented there, and you see James Webb as a different can observe on a different wavelengths that the Hubble Space Telescope used to observe. So it will primarily observe the infrared, in the infrared. Now, why infrared? So we have a picture on the left from Hubble, and on the right we have a picture from the James Webb. As you see from the visible light in these molecular clouds, where we have formation of new stars, there is lots of dust concentrated, and light cannot be penetrated, so we cannot observe it. But with the infrared light, of course, we can see what's hiding behind the dusty shroud. So that's why it is really interesting, because this is what happens also when trying to observe the earliest forming galaxies and earliest stars. So we talked about the wavelength, and now we're going to talk about the overall size. So on the left we have the James Webb, on the right is the Space Telescope. So it's a little bit bigger in the overall size, but the main point is the mirror. So if you have a look at the mirrors, this is the mirror of the James Webb Space Telescope, and this is the mirror of Hubble. And I will show you now is 2.5 with 6.5 meters. There's a lot of difference, and as you can see, we have cells here. The reason is that because we couldn't make a very large primary mirror all together, because it would have collapsed because of its own weight. But it's also better for focusing, because they can use individual cells to focus better. So according to the calculations, there is 6.25 times more collecting area on the primary mirror of the Webb telescope compared to Hubble. Now, something very important for it to be operating, the seals. Now, the sun and this is the sun shield. So the sun shield has approximately the size of a tennis court, or it is described by NASA half as big as a 737 aircraft. But they are very important because it protects the mirrors and observations from the light that comes from the sun. And I will explain how. Now, as you see here, there's from the sun is approximately 150 million kilometers. And the Earth, the average distance is 384,000 kilometers, and Hubble's is orbiting around Earth at 570,000 kilometers. But Webb is 1.5 million kilometers away at Lagrange 2 point, which is opposite to the sun. So as the Earth is orbiting the sun, this is orbiting around the Earth and the sun at the same time. So it's always at the other side of the sun, and this shield is also directed from the other side of the sun. So this shield here protects it from any source of light from the sun. Of course, especially in the infrared, there would have been lots of noise on the images. And now we have a picture here that we, as we see, the age of the universe since the Big Bang. And if we are looking backwards towards the Big Bang, and we see where the Hubble Space Telescope observed in the deep field, Chandra, and then we see James Webb Space Telescope that has already captured some gray, not really well-formed galaxies that it seems that they are at the beginning. They are baby galaxies and not toddlers as those observed by Hubble Space Telescope. And it has also proved that Einstein's general relativity actually comes into play and the universe expands. Now the rate of expansion maybe it has changed, but it still expands. So this is one of the main things that James Webb Space Telescope has proved up to now. And of course, one of the very important things, the Dymiotis sulfate that was discovered on in the atmosphere of those planets. And I would like to say a big thank you publicly to Dr. Alex Lockwood. It was a great pleasure to meet her she shared her knowledge with us, and she's willing to help outreach and research, and she's also got to give a speech on a talk on our online science cafe. So most probably in the next couple of months, after she goes back to the States, she promised she will send me an email and further contacts, and we will be discussing when she will give the lecture. So big thank you, Dr. Alex. And I will finish my presentation here with an image of the galaxy, of this galaxy, and you can see that it's divided into two. So it's a combination of the Hubble Space Telescope imaging in the visible light and combination of the infrared and the near infrared images of James Webb Space Telescope. Actually, it can observe only in a small portion of the visible light between red and yellow. So this is what we get behind the star, the center of the galaxy, where it has a lot of dust. So this is a beautiful image combined from two images combined from the two telescopes. Hubble on the top and James Webb Space Telescope at the bottom. So thank you for being with us today for this lecture. And we would like to inform you that during, if you want to participate in any kind of research during the summer, if you want to participate as volunteers at the KITION Planetarium Observatory, you're more than welcome. We are planning to host astro party events for tourists instead of doing them here, because they are actually developing the area here with the sewage, so the tourists cannot have access here. So we are going to design the private events for remote places. In some places in Larnaca, in Famagusta, in Nicosia, in Paphos, in Troodos, in Limassol, in Agamas. So if you're willing to participate and to get this experience of the night sky, we will be offering night sky tours with the laser. It's going to be a good practice for you as well for your challenges that you will receive in the Olympiad, because some of the constellations, like Scorpio, for example, is visible from the southern hemisphere, and it will be a good practice for you, especially with the laser, and to find some targets with the Dobsonian. Thank you very much. Any questions? No question. Now, on my behalf and of our team, representing the KITION Planetarium Observatory, I would like to congratulate our students that you are also here participating today for achieving gold and silver medals and going to Brazil to represent our country. We are very proud of you guys. Keep up the good work. And also big congratulations to Alexander Prokofiev for instructing you and solving the past papers, and great work. Alexander, would you like to say something, please?
Thank you. Actually, we have a KITION Astronomy Academy. Anyone could join it. At the moment, anyone, because of we don't have limits yet. But that's all. We just have vision at our KITION Planetarium and Observatory programs, which correspond to mathematics level of students, to the study in physics parallel, and mostly the concept is everything should be given in the proper time. So we discussed cosmology in details, for example, last year when it is already discussed in school, like special relativity. We don't do that at the beginning. We do details which are possible to understand for mind of gymnasium students, but we don't do it more advanced details because we are waiting for school to explain children what's going on. Well, and it is good that really some students of our Astronomy Academy, this year we participated a lot of students, but 4 got excellent results, 3 medals, and 1 was taken, Ara Mahdessian was taken to represent International Olympiad without passing the Olympiad itself. Okay, boys, could you say some words by yourself? Is Michalis here?
Mr. Dymiotis.
No, I want to hear Michalis Dymiotis.
Michalis was here, now he left because he has an exam tomorrow.
Okay, could you represent him?
No, he
tell
could.
Tell us what he's talking. What he tells you about the Astronomy Academy.
Actually, I wanted to hear him because of him.
Yeah, of course.
They are completely new, but you already know something in astronomy. But he was first time practically knows something in astronomy based on our KITION Astronomy Academy. Okay. Anyway, let's start with Michalis. Oh, Michalis, sorry, with Kyriakos. Could you say a few words about how you found this Astronomy Academy and how was it helpful for you?
Yeah, I think it was really helpful for me to keep in touch with astronomy and astrophysics because previous years I maybe forgot some things and then I had to study again and remember many formulas and stuff like that. And I think this whole academy helped me to keep in touch and also learn, of course, learn new stuff and also learn ways to solve exercises, like the method and the strategy to solve an exercise.
You mean to write answer from beginning?
No, like given and stuff like.
It's a usual problem with the students. They go directly to the end, they write the answer without showing the steps, and usually they lose a lot of marks, especially in the area levels.
No, actually, it is a method which we apply. So just not to forget where we are coming to. Usually, the final what they asked is just one formula. So write that formula at the beginning. This way, you show that yes, you know where you are going.
It's good because sometimes you lose your concentration, you carry on on different path, or if you paste a number wrongly, it means that you will not lose the marks, because it shows how you think and it shows that you know what you're doing.
Okay. Then let's ask Matvey.
Yes. So the academy really helped me. It got me into astronomy, into the whole science and stuff, and helped me to qualify for the International Olympiad, which I am very excited for. It's my first time I will go to the other country for Olympiad.
Yeah,
Bravo, Matvey.
it's good experience. Matvey,
We are very proud of all of you.
maybe you may give some details. What did you find something similar when you solved these tasks at Cyprus Olympiad? You won gold medal. So was there something similar which helps you, or which strategy helped you? I don't know. So tell some words. How you came to gold medal, not just participated and occasionally. Here it is.
Yes, the most important is practice, just to solve as many tasks as you can, and also learn some theory. But solving tasks is the most important, I think.
This year we solved some tasks. Were there some new tasks or methods which you use this year was particular in Cyprus Olympiad useful, or just generally?
More generally. This time, the previous time I forgot some formulas and I was more confused. This time I studied more and did better.
I see. And how do you study to Olympiad itself? I mean, you don't use only our lessons at KITION Astronomy Academy.
I solved previous papers.
Okay, and how much time it took?
Oh, 2 to 3 hours per paper.
Okay. So so if the Olympiad is tomorrow, you start yesterday.
No, you start at least from a month ago, month before the Olympiad.
Yeah, not at least. In this particular year.
Well, this particular year was 2 or 3 weeks before the Olympiad.
So you started 3 weeks before.
Yes, something like that.
Okay. How do you think you know that? And if I remember, you won again in physics Olympiad.
Yes.
Opportunity to speak up.
Yes. It's so well. I took the second place. It was also just solving fast tasks and getting good at solving the hard physics questions.
Okay, and give advice when it should be started.
Well, like 2 months before the Olympiad.
So for physics, you started even 2 months before Olympiad.
Well, it like maybe 2 months before the Olympiad, I just started looking up what's going on there, what are generally the tasks, what's the theory, what I need to learn. And as the time get closer, I studied more and more.
I see. So we may say about a month.
Yes.
Before. Okay. Thank you. And what Ara could say, Ara?
Yes. Also, for me, the lessons that we do with you, Mr. Alexander, are very helpful, especially this year that we started doing more advanced topics like general relativity and more cosmology. They are new things, and I like learning about them, and I'm sure they will be helpful for some questions in Brazil.
And tell how you managed not to participate in Cyprus Olympiad, but nevertheless represent Cyprus and Brazil.
So I did sit the paper in Bulgaria, in the hotel that we were going to do the BMO, or we were staying for the BMO. And I think I did well, but they didn't put my name on the list because, wait, it's because I had got the gold medal last year in the IOAA, and there's a rule in the Enos Physikon Gypru that if someone gets a gold medal, they can participate the next year without sitting the exam. So they didn't put my name.
I see. Okay, and could you explain which you use abbreviations, but not everyone understands it?
IOAA is International Olympiad on Astronomy and Astrophysics. It's the thing we will go to Brazil.
And last year, where was it?
Poland.
Okay, and the other one you use for Mathematical Olympiad?
And the BMO is the Balkan Mathematical Olympiad.
Okay, and how it happened that you was there?
If you have to pass the selection test for that as well. It's the Barchiagad and the Bangipria, and those who pass the Bangipria can participate in the selection test. There were 3, and those who do, or the best 5 or 6, I don't remember, go to the BMO.
I see. Okay, so it's not just to win in Cyprus Olympiad, there is some preparation activity as well.
Yes. So if, for example, approximately 15 people pass from each year, I'm in Lyceum, so 15 people from Alpha Lyceum, 15 people from Vita, 15 people from Gamma. So these 45 people can participate in the selection test, and the top 5 or 6 go to the Olympiad.
So congratulations, you
Thank you.
participated there as well.
Yes.
Thank you, boys.
Excellent, guys, excellent. We are always here for you. Anytime you need anything, let us know. We're here to support you. And we are really, really proud of you guys, all of you. So thank you very much for joining tonight. Our next Science Cafe will take place last Tuesday of June. Stay tuned.